Welcome, everyone, to the RASC Edmonton Centre February monthly meeting. I am Jay Lavender, your host for this evening and the current presiding president for the Edmonton Centre. So we got a pretty exciting lineup for you tonight. So we'll just get things underway. I hope everyone can see the agenda there. Of course, we have our two standard housekeeping items that we need to get underway, get out of the way first, and then we'll bring up our speakers. So first off, our January 8th, 2024 monthly meeting minutes have been posted to the OneDrive. Are there any errors and or omissions? Okay, then hearing none, I will ask Madam Secretary.
I move that the January 8th meeting minutes be approved as posted on the OneDrive.
Thank you. Do I have a seconder? Luca Vanzella. All right. For members only, all those in favor? Any opposed? Okay, motion is carried. Thank you. Okay. So tonight we have a couple of veteran guest speakers, and I will ask Dr. Morsink to please come up and introduce our speakers tonight.
Hello, everybody. I'm really excited to introduce two guest speakers tonight. At the University of Alberta, we have a student group called AlbertaSat, and I hope you've already heard about them because, of course, they are responsible for building and launching Alberta's first satellite into space. We have two representatives from that group, Nabiha Saghar and Sam Bradford, who are both U of A students. Nabiha is a third-year physics student, and Sam is a fourth-year electrical engineering student. And I don't know where they went, but oh, here they are. Here you go.
Thank you for the introduction. So yes, we are from a student club at the U of A called AlbertaSat. And so we're just going to talk about what we do and who we are. So I have a BS, I'm working on my BSc on my BSc in physics, and I'm minoring in creative writing. Closer to the mic. Okay, so I am part of the outreach team and the IRIS team, which is our imaging payload. And yeah.
Hi everyone, my name is Sam Bradford. I'm studying my BSc in electrical engineering with a minor in mathematics, and I've just joined. Oh, thank you so much. Is this a good volume? Yeah, okay. And I just joined the onboard computer team in September, which has been fantastic. I really like to learn new things, and I've deluded myself into thinking that I can play the guitar very recently. So it's a little bit about me.
So on the agenda today, what is AlbertaSat? We're going to be talking about our primary missions and some of our submissions. So our satellites are called Exalta-1, Exalta-2, and Exalta-3. We are currently working on Exalta-3. We had just launched Exalta-2 in April 2023, and it kind of experienced its entire lifetime, and then eventually its orbit decayed and it burned up in the atmosphere. And Exalta-1 was our very first satellite, and its primary payload was a DFGM, a digital flux gate magnetometer, and it basically measured space weather. So that was from the Northern Spirit mission, Exalta-1 was, and sorry, Exalta-2 was, and then Exalta-1 was from the QB50 mission. Cool.
So the University of Alberta, working with AlbertaSat, designs a class of satellites called nanosatellites. They're about the size of I think it says they're a duck or a raccoon. This is one that we have here. It's a mass model, so it hasn't been in space, but it's supposed to be a accurate representation of what it looks like. It is comprised of 3 10 by 10 by 10 centimeter blocks. And this is the class of satellites that we send up. This has been what Exalta 1, Exalta 2, and what Exalta 3 will be. So Exalta's 1 mission was primarily focused on gathering information about space weather, particularly plasma interference with the Earth's magnetosphere. It featured a big boom you can see there with the DFGM, which is a digital flux gate magnetometer. This was a delicate device that measures the magnetosphere. And it was extended on a boom because it needed to be far away from the satellite due to the electronics of the satellite producing their own magnetic field, which could interfere with data collection. So this was in Cape Canaveral in Florida. This is the launch of Exalta 1. AlbertaSat members were lucky enough to be there to witness this happen, which was very exciting.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. Go for main engine start. 1, 0, and liftoff of the Atlas V rocket with Cygnus and the SS John Glenn, extending the research legacy for living and working in space.
So we'll let that play for a little bit. It is going to intercept at the International Space Station, which is where these satellites are received. So once the ISS received it, they used it was nanoracks to launch out the satellite into its orbit, which it maintained for 18 months. So this was a very big moment for Alberta because it was Alberta's first satellite, and all the more impressive that it was a student group who was able to do this.
We like to call the CubeSat deployer something like a Pez dispenser. I don't know if you've seen those little candy machines and they kind of shoot out the candy. So that's what I like to liken it to. So our second mission was Exalta 2, and so it was our wildfire camera. So its purpose was to track and assess wildfires and to predict the behavior of future wildfires, because we were inspired by the unfortunate happenings of the Fort McMurray fires, and it's said that about 60% of wildfires are caused by man, and so things like logging and mining and such. And so we want to help firefighters make informed decisions and communities to be informed about the progression of fires and also the aerosol and smoke. So the properties that Exalta 2 could study through its imager would be active burn detection, vegetation analysis, post-burn effects, and smoke and aerosol detection. So perhaps we could play somewhat of a matching game and try to see. For the first image on the top left, what property do you think we'd be assessing there? You could just shout it out. Smoke? See, absolutely correct. And then the one right beside it, top right. Vegetation? Absolutely. And then the bottom left? Yes. And then the last one is active burn detection. Awesome. Yeah. So our imager had one band, and so what that means is it was visible near infrared light, and so it would be able to assess the characteristics of image targets that reflect back visible light, and fires themselves emit thermal energy. So that's what we have the near infrared for. So yeah, so the issue with wildfire analysis is also that there's going to be an atmosphere around the Earth. And so as it goes for all Earth observation missions, so the important thing is to know what your imaging targets are and what your what's going to impact the quality of that image. And so smoke is something that's not as transmissive as as air. And so that means that light that gets passed through the smoke will not accurately reflect the imaging target. And so that's why we have to have different wavelengths that this imager is able to collect. And so these imagers aren't able to take an entire image of the Earth all at once. And so through a pass, one period of an orbit, it takes about 90 minutes. And I think the ISS is about 110 minutes. So it's quite quick. It takes these images in swaths. And then as it completes passes, these swaths can be collimated into an entire image. And these images aren't images that we kind of are used to seeing, like ones that come directly from our phone. These are more raw data that we can then use post-processing methods to then create an image that we can understand. Okay, for XLTA-3, we kind of pivoted, and even though we're still going to be able to image wildfires, we're more focusing on monitoring ice and snow coverage. As well as continuing on with our magnetosphere research for space weather. So we still have our digital flux gauge magnetometer. And so the orbits for XLTA-1 and 2 were geosynchronous orbits following the ISS, but our intentions for XLTA-3 are to have a sun-synchronous orbit, which means that, for example, if our satellite passed over a specific spot in Germany at 6 a.m., it'll pass over that exact same spot at 6 p.m. So that gives us a temporal resolution, or sorry, a spatial resolution at that very same time kind of thing. So we can do a comparison of what happened during that day. And then the other aspect to this mission is to prove that a student group can continually produce quality work that can gain space heritage. So the way our imager works is with a system of lenses, and this system of lenses has to be designed for the different bands that we're working on. And so for XLTA-3, we have a band called VNIR, and we have a band called SWIR. So VNIR is visible near infrared light, and SWIR is shortwave infrared. And so both of these bands tell us different things about our imaging targets. So the reflectance of snow and ice are quite different from the reflectance of dry fuel, like dead trees, or even like live vegetation. So, yep.
Okay, now we're going to talk a little bit more about how the computers work on board these satellites. XLTA-1 and 2 were very special because they were built, these OBCs, these onboard computers, were built in-house, designed by students and with the help of professors. And they perform very well. One thing that they don't have, which is very important for these very expensive missions in terms of their reliability, is having flight heritage. So when we've had an OBC that has been in space and we know to have performed well in space, that's quite valuable to us in terms of guaranteeing the reliability of the satellite. This is our new OBC. It's called the Xiphos Q7S. It is very, very important. Sorry, pardon me. It has flight heritage, which is very important. It's been in space. We know it works in space, and it features quite a few very attractive properties. It has a dual core processor, which contributes to its really robust fault tolerancing, which is very important in space. It has a very low power draw, about 2 watts nominal, if that means anything, and features quite a few different communication protocols that allows it to interface with very many different components within the satellite, which is important, especially for interfacing with IRIS, as you talked about before. So before we talk about computers a little bit more, we need to talk about ionizing radiation and cosmic radiation and why these things are bad for computers. Ionizing radiation can come in many forms and could come from many sources. Solar sources is a large one, as well as other cosmic sources. Higher energy particles are very bad for modern day computers because modern day computers feature very, very small parts. Transistors today are on the scale of 10 to 20 nanometers, which is maybe 100 atoms wide. So high energy particles or alpha particles could disrupt this. They could flip a bit, which is a big problem in space because we can't get to it and we can't fix it. So we have to instill properties within our system to make sure that when these faults occur, which they will, they can be prevented from manifesting into an error. We'll talk about that a little bit. Some of the methods that our new OBC will employ to prevent this from happening. One very simple way that the XIFOS QS7 prevents, or Q7S, pardon me, prevents these errors is through N modular redundancy, which is very commonly triple modular redundancy. This is a very simple mitigation technique that is used. You have 3 different processors process the exact same information, and it's likely that at some point in time, one of them will experience a fault. A cosmic ray will flip a bit, and gate 1 might be incorrect. But we can rely on 2 of those 3 to be correct, and then a voter will vote based on the majority, and we can assume that to be correct. So this is a great way to increase the reliability of the system. Another way that this is done is through triplicated processor memory, which you can see on the right there. That's where you have these voting mechanisms intertwined between the processor and the memory, so that if a processor fault occurs, the memory side will save the correct data and vice versa. So away from hardware a little bit, something that we do in software as well when we're designing our systems is error correcting codes. This is the same technology that's used in CDs. If you've ever gotten your CD a little bit dirty or scratched it, you'll notice it most of the time will work anyway, even though that it's missing some data, which is really cool. This is because of a 70-year-old mathematical property that was discovered by Richard Hamming that is employed by us. By instilling some extra bits, some extra information along with our data. For instance, if we were to take a picture of Canada's northern regions and it was corrupted by a cosmic ray, we could maintain the quality of that image. We could prevent it from being degraded if we were to also store extra bits that tell us a little bit about the information that's encoded. Typically, these bits will be positioned in very special places, and their number will tell us self-referentially about the data it contains. So it would be something like all the data in this block adds up to an even number. And by using fairly few redundancy bits, you can maintain the security of your data and not know that not only a bit has flipped, but know which one flipped and flip it back, which is incredibly important when using satellite technology. You can see on the right here that the more data you have, the fewer redundancy bits, like percentage of redundancy bits you need as you get to 4,095 bits, for instance. You can store all your data securely with fewer than 1% of that as redundancy.
Cool. So we spoke of our primary missions, our Exaltas, but we also have submissions. So one of the submissions that I got to partake in was the CANRGX competition, the Canadian Reduced Gravity Experiment. So what gets to happen there is you submit a proposal for an experiment that you want to try in microgravity. And the way this microgravity environment is induced is through parabolic flight. So what happens is there's an aircraft specifically designed for parabolic flight, the Falcon 20, which is the National Research Council's plane. And so this plane will start out going through a parabola. And then once it reaches about halfway, it's at about a 40-degree angle. And this angle allows the plane to coast through the rest of that parabola, which is about 30 seconds worth. And so as it's coasting through this parabola at that specific angle, you're kind of in the plane. And so it's as if you are in a microgravity environment. And then as it descends through the parabola, microgravity eventually ends, and then you reach 2G, which is twice gravity, and then you eventually reach level flight, which is 1G, normal gravity, and that's where you can reset your experiment and stuff. And so our CanRGX experiment was the passive capture of space debris, because we noticed that all the methods that are currently being used are quite financially costly and also time-wise very costly. Like there was like this ion beam that would hit debris, but then you have to be very precise, and then you also have to hit it multiple times to eventually knock that debris out of its original trajectory. The other thing that existed was NASA's gecko grippers, and these gecko grippers worked on the basis of van der Waals forces. And so van der Waals forces are quite weak, and they're more surface forces. So the electrons on the surface of the material, this polymer, will interact with the electrons on the surface of whatever it's adhering to, and then you form temporary bonds. And so that's what we ended up using. We used gecko adhesives, but instead of making a gripping claw or something like that, we decided to create kind of a net. And we were able to take simulated debris pieces out of like cold rolled steel, and we had different surface areas, and we had 4 different chambers, and in each chamber there was a launching mechanism, a piece of debris, and at the top of the chamber there was our gecko adhesive nets. And so we also had what we call a strain limiting layer to form the net, and what that is kind of like preventing the debris from ripping through the gecko adhesives in case the adhesive ended up being too weak to withstand the velocities of actual debris. As it turned out, our velocities were not great enough to rip through the gecko adhesive, so we didn't have to really worry about that. But we learned quite a bit about debris dynamics and just how, like, everything is so perturbable in microgravity environments. It's crazy. Like, we thought that like you'd have a piece of debris and then you'd launch it and it would remain planar. And then you'd get a really good adhering surface. But what ended up happening is at the beginning of launching some of our debris pieces, they would initially start skewing and then like ricochet around the chamber. And so we had to, in our next data flight, we ended up having to make some adjustments to our launching mechanism to ensure that debris didn't fall between tiny little cracks or just like not even end up hitting the net. And so we learned quite a bit about that stuff. And we also did a bunch of outreach, which is really important to me. I love doing outreach. I think it's important to share space and science and making it accessible. Yeah. So yeah, on the left, you can see our launching mechanism, just a render of it. And then in the middle at the top, you can see our strain limiting layer. And then on the bottom, we have this material, and we cut specific patterns into this material. And these patterns are like auxetics. And what auxetics are is they allow a material that originally won't deform as much as it could. These cuts allow the material to deform even more. So if you were to throw a ball at a wall, it would kind of just ricochet off. But if you were to throw a ball into like a trampoline, the trampoline would deform before the ball ricocheted back up. So in incorporating auxetics into our gecko adhesive, we were allowing that adhesive to conform more to the debris. And so that was quite key. So here we have a demo of these gecko adhesives. And so there's these tiny little fibers on the surface that we molded into it. So it's like a dry adhesive. So it does not have any residue. It's basically just the morphology, or basically just the surface area of it. And so in having fibers, you're allowing yourself to create more of a surface area. And so these fibers look kind of like suction cups. Suction
I'll
cups.
get this over here, sorry.
Yeah, maybe. Yeah, on the bottom right, you can see a microscopic image, and that's what these fibers look like. And so the adhesion quality depends on fiber height and the diameter of the fibers, and less on the material itself. So I guess we can, if you want to peel it off.
It's good at its job.
So you could kind of hear that peeling sound. And so that's the sound of like the fibers being pulled away from the surface. If you were to take this adhesive and you were to pull on it parallel to its surface, parallel to the surface.
Sorry.
Yeah, it's not going to come off because all the fibers are acting together. Yeah, all the fibers are acting together to remain adhered to the surface. And so it's quite nice. It works very well.
Doesn't feel sticky.
So yeah, thank you for listening. We talked a lot. It was quite an indulgent talk. We were mostly focusing on what we're good at. And so if you have questions about the structure of the club and other things like that, we'd be happy to elaborate. Thank you.
Okay, if anyone online has questions, you can just unmute yourself, and I'm not going to run around. So if anyone here has a question, please just stand up and they'll repeat the question so folks online can hear your question.
Who finances your club?
Who finances our club? So a lot of generous donors, the CSA. So the mission that we're part of now is called the Cubics mission. And so we get a little bit of funding there, and the brunt of the cost is usually launch and prototyping and stuff like that. So it's a lot of donors, and that's why outreach is super important as well. Yeah, so that's another thing is like you'll have batches of satellites being sent up. It depends on if your satellite's going to be in a constellation with others. So that usually requires a little bit more planning, and it depends on your orbit type as well. So our first satellite was launched by NASA, our first two, and then our second one was launched by SpaceX. And those were loaded up onto the ISS, and NanoRac's CubeSat deployer helped us out for that. Yes. How do you stabilize the satellite? Would you like to take this one?
Sure. There's an entire sub-team in AlbertaSat particularly concerned with this issue with orienting the satellite properly. It has to do quite a bit with the physics of the moments of inertia, which are handled to maintain precise imaging as it circles the Earth. This is something that it does initially as soon as it's launched out. It figures out where it is and orients itself properly to prevent gyroscopic precession is the word I was looking for. Yeah, sorry. No, the ADCS club is the third sub team is the team that does that.
So the attitude determination control system, it's basically kind of controlling the momentum of the satellite. So it doesn't have any propulsion. It's more just an orientation thing. And so it has these things called reaction wheels. And so these reaction wheels turn a little bit. So I'm not on the AECS team. So this is my understanding is that they rotate, and this rotation kind of translates into kind of an orientation. Yeah. Effectively, yeah. That's a great question. How do we stay in contact with our satellite? We use amateur radio, and we have 3 ground stations. And these ground stations are able to communicate with our UHF antennas. I think that's what it is. And so we're able to even send our data that we've collected from our imager, from our sensors, and then send it to our ground station throughout the passes that it makes.
I imagine there's other university clubs across the country doing the same thing, right? How does Alberta measure that space race?
How does Alberta measure in the space race? Well, I don't know. I think there's a lot of universities that are very good at a lot of things, and I think we're very good at specific aspects of satellite design. So I think our outreach team is amazing, and I'm not biased at all, I promise. Thank you. Yes. And so I think community engagement is a huge aspect of science. And so I think we're winning in that regard. And in terms of being the first people to send a satellite up in Alberta, and then being the first student group to do so in Canada. I think that's a huge marker. And even as it goes, like we're in communication with a bunch of universities who are working on their own CubeSat missions. And so we end up taking advice from each other, and we learn a lot from them and they learn a lot from us. So I think we're all kind of working together for our various missions. I think that's a great question. It was more, once we begin to scale it up, like once we get all of this preliminary science out of the way, we gotta scale it up. And then our intention was to put it on one of our CubeSats and then kind of have it like a fly trap, just floating around. And we're thinking of like matching relative velocities. Like there's stuff to consider that way because the debris have varying velocities, and so they could be traveling quite quick. And our inspiration for that, I had not mentioned, was the fact that there was a hole torn in the Canadarm2's thermal blanket, and it caused like a small hole. And so that was a concern. So yeah, stuff can be quick.
Okay, any questions online from anyone online? Going once, going twice. Okay, guess not. All right. Well, thank you again, everyone. Please join me in thanking them for their efforts. Very interesting stuff. So very much appreciated. Thank you. You get to keep the satellite. Okay. So we'll move on to, we have a couple of announcements. So I think Dave Mussel is not here today, but he is online, I believe. So Dave has an announcement to make. Dave, are you there?
Yeah, I'm here. Can you hear me okay?
Yep, we can hear you. Go ahead.
Well, thank you, Jay. I'm just here to give a brief announcement about the progress that we've made in the volunteer registration drive, and to talk briefly about some of the changes that we've made to our website and some other information. But off the top, I have to say I'm really pleased and blown away by the response that I've gotten to the letters and other communications that I put out to inform the membership about the opportunity to register as volunteers. It's been just great. Very high rate of response, and very enthusiastic response as well. As of right now, I think we have 39, possibly 40 registered volunteers, and these are, of course, all the people that have been volunteering, the usual suspects, as we call them, and people who have been veteran volunteers for years, but also a number of new people that have signed up as well. And so we've got around 10 new volunteers who have yet to be invited to participate or volunteer in any of the activities. So this is all very exciting. And so really good group. Many people who have been involved with the Northern Prairie Star Party, the Jasper Dark Sky Festival, the events that we have in Edmonton. And these are not always just astronomy events. These volunteer opportunities often encompass logistics, setting things up, taking things down, cleaning, organizing, delivering, many other types of activities. So it takes a lot of people doing a lot of different things to help some of these activities get off the ground. And so I'm really excited about that, the number and the quality of the volunteers that we have. So yeah, just also a quick word to the coordinators. So there's a number of people in the club who coordinate these projects and coordinate activities and events. And most of you know who you are. And I encourage the coordinators to now look at the list of volunteers, which is visible to them via your VicNet connection. So if you go to VicNet, you can look at the schedule. You can also look at the list of volunteers, and you'll see that we've got a lot of depth there. It's really quite impressive. So the new people, as well as the veteran volunteers who have signed up. And so it's the opportunity is there for the coordinators to be able to start matching volunteers who are on that list with the jobs that they have for in this coming year. And so I'm hoping that that'll start to produce lots of new activity and engagement, and make it a lot easier for people who are looking for volunteer help to find the people that are qualified for the work that they want to get done. So that includes includes the casinos, the astronomy interpretation events like sidewalk astronomy around Telus World of Science, trips out to Elk Island Park or to Jasper or wherever those events are happening, and all the support activities that go along with that. So there are people now in the list that you coordinators can look at. You can see who's there and begin to draw up your list of people and start assigning those roles and responsibilities to people in the club. And finally, I would just want to mention the webpage. With the help of Luca and Ryan, we've gotten some new content there for volunteers to be able to access. So if you go to the webpage, the RASC BC Edmonton Center webpage, there's a new tab under the members area called Volunteers. And when you click on that tab, it'll open and you'll see resources that are available to the volunteers. So there's the sign-up sheet that you need to fill in order to get registered and onto the roster for volunteering. And any new events and projects that are looking for volunteers will be advertised there as well. I'm so thankful for the website. It's a way for anybody who has not heard from me to be able to get access to the roster and to be able to get themselves registered. So any members who are hearing this and have not yet signed up to become a volunteer, that's your opportunity. Go to the members page on the website and you can access the application form, or the registration form, I call it, and get yourself on the roster. So that's it from me. I'm very thankful for the great response that we've gotten so far. I anticipate that after we're finished, or when it starts to taper off, we'll have around 60 registered volunteers, which is a really good, healthy number. And so keep going back to that page. The content will change. New events will be announced there, and any new forms or resources that you'll need for volunteering will be posted there as well. So thanks, Jay. That's it for me.
Okay, thank you, Dave. And really just to add on to that, I had never thought I would ever volunteer at outreach events and that sort of thing until I did it. And it's a lot of fun. I mean, I love astronomy, but something I love just as much is sharing it with other folks and other communities and that sort of thing. So it's a really great experience. So if you're thinking about it, go to the webpage and sign up. Okay, next speaker, our Vice President and Outreach Coordinator, Clayton No.
Thanks, Jay. Just want to let people know that Frank Florian and I are involved in a movie production that's going to take place later this year. And the movie's going to be called Physics for Poet. And basically it's the Inquisition around Galileo, when they were trying to get him to recant his view of the solar system and the universe. And so this movie is going to be shot in the last 2 weeks of May for the majority of the shooting down at the Orange Hub, which is the old Grant McEwen college location on 156th Street, just off Stony Plain Road. One of the scenes in this particular movie will be during the Inquisition, where there's a number of inquisitors, and we're not sure the number we're going to be looking at yet, but it'll be probably between 8 and 12. So we need volunteers from the Royal Astronomical Society who would like to take part in this movie by being inquisitors and being able to shout questions at Galileo. All the actors have been hired for that. Our part of it will be volunteer, so we'll be putting out a volunteer request. So they had last year sometime they had a reading of a play, which this movie is based on, that was done here in the Zeidler Dome. And the interesting part was the people were just shouting the questions out from the audience. Where in this particular movie, you will be actually probably on screen and you'll be wearing an outfit that they've already procured. And so that will be supplied, there'll be meals supplied. So if anybody's interested, just please drop me an email to the vice president email on you can find on the website. And I'll also have a write-up in the March Stardust with all the details of what's going to be required. And hopefully we'll have some photos of some of the people in costume and how it's going to look and going forward. So if anybody's interested, we sure like to see it. They've already cast me as one of them because of the beard and my age, I believe. So it's going to be a fun time. So if they're interested, just drop me a line and we'll see if we can get everybody involved. And I think it'll be a lot of fun to see this thing. And it should be out for, its premiere late fall, early winter of this year. Thanks, Jake.
Okay, so there's your chance for 15 minutes of fame. Or less, just saying. Okay, we had one late addition to our announcements. So Murray Paulson, come on up.
Now, I know most of you understand that I'm a fan of meteorites. And so this meeting just happens to fall on the anniversary of the Shikoty-Alin meteorite impact over the Shikoty-Alin Mountains in Siberia in 1947 on February 12th. So I've brought a couple meteorites from this particular fall, and they will be available with me at the break. And also, we're also heading into the 11th anniversary of the Chelyabinsk meteorite impact event over the USSR. And so I've also brought a couple stones from this impact. Both meteorites have produced quite a gestalt in the meteorite community about what these things can do. The Shikoty-Alin meteorite, the pre-atmospheric weight was probably about 100 tons, and they've recovered about 25 tons of material around it. The Chelyabinsk, it was something that was probably about 50 feet in diameter, and it produced about a half a megaton of energy disruption, about 30 kilometers off the ground. I'm really, really glad that didn't happen in the days before detente. Anyway, please come by and have a look at these wonderful stones. Thank you.
Okay, thank you, Murray. Always interesting. So if you do get a chance, please go over and take a look. Okay, we'll take a break here, but before we do, we'll just hopefully fire up. This is our astronomical trivia. Name that object. Bonus points if you know the catalog designation, if you actually know the better known moniker or the resident constellation. So answers in the So we'll present at the end of the meeting the answers to the trivia. And until then, let's take a 10-minute break. Well, hopefully everybody got a good look at the mystery object today. Okay, so let's get going with the last half here if we can. I'd like to call up Mr. Mark Zalchik for Book of the Month. He's here.
Thank you. Good evening. We'll start off by mentioning that Alistair Ling and Doug Hube graciously brought some books to give away, and they are on the ledge right over there. Thanks to Alistair and Doug. And there's some surplus books a little further down the ledge from the library, which is located just off the main entrance to the Star Theatre. It's open before and after the meetings. Berta Beltran, the co-librarian, is actually in attendance tonight. Hello, Berta. Last meeting, there was a very interesting talk by Laurie Walton on SETI, and she mentioned a seminal volume on the subject, The Living Universe, NASA and the Development of Astrobiology, and suggested it'd be a good book for the library. Ta-da! Here it is. The Living Universe is a comprehensive, historically nuanced study of the formation of the new scientific discipline of exobiology and its transformation into astrobiology. Among many other themes, the authors analyze how research on the origin of life became wedded to the search for life on other planets and for extraterrestrial intelligence. Many scientific breakthroughs of the last 40 years were either directly supported or indirectly spun off from NASA's exobiology program, including cell symbiosis, the discovery of the archaea, and the theories of nuclear winter and the asteroid extinction of the dinosaurs. Exobiology and astrobiology have generated public fascination, enormous public relations benefits for NASA, and on the flip side of the coin, some of the most heated political wrangling ever seen in government science funding. Dick and Strick, the authors, provide a riveting overview of the search of life throughout the universe, with all the earthly complexities of a science in the making and the imperfect humans called scientists. Their book will appeal to biologists, historians, and philosophers of science, planetary scientists, including geologists, and an education general readership interested in the investigation of life on other planets. So the book is available after the meeting. So thank you very much.
Thank you, Mark. And again, just to clarify, borrowed books that way, you can keep books and magazines that way. Okay, it's my public service announcement. Okay, Astro-Imaging Corner. Abdur, I think I saw you online.
Yep, I'm here.
Stop my
Thanks,
share.
Jay.
Over to you.
Perfect, thank you. Okay, I am going to share my screen. Thank you. Okay, so welcome to Astro-Imaging Corner number 133. So for this one, I included all the images from that I received for February, as well as the ones from January, since for January we had done a review of the entire 2023 year instead. So our first image for today is from Professor Brian Martin, and this is a recent shot of Messier 42, the Orion Nebula. And this is it's a wonderful sight even in a small telescope, and this image was taken with LRGB filters in 10, 30, 120 and 300 second sequences with the ASI 1600 camera and a stellar view 102 millimeter f5.6 telescope. And this is a total of 4 hours of data, and it took about another 4 hours for processing. And Brian said that he used SPCC to get an accurate color balance and HDR composition in PixInsight, as well as StarNet 2 to process the nebulosity and stars separately to help bring out the core a little bit more, and also to bring out some of the faint nebulosity outside the nebula. So great shot there, Brian. Up next is another shot from Brian. This is Comet 12P, Pons Brooks. And this was taken fairly recently on November 24, and the comet was still showing the aftermath of a recent cryovolcanic outburst at the time. And this image is a sum of 50 exposures of 1 minute each at 2000 millimeter focal length with an ASI 294 MC camera and a 10-inch RC telescope. And Brian says that 12P Ponsbrooks is a Halley-class comet with a period of about 71 years. And since Brian is 18 kilometers east of Edmonton, the comet was in the west, in the middle of the most light-polluted part of the sky. So the sky gradients were pretty ugly, but using PixInsight and StarNet 2 and using the comet alignment tools, Brian was able to get some pretty good detail in the coma as well as the outer regions of the comet. So great shot there. Up next is an image from Al. This was created using a Canon R6 and a 2x Barlow with eyepiece projection with a 27 millimeter panoptic eyepiece. And this was taken on January 18, and the stacking or processing was done in Planetary System Stacker, and the resulting image was processed in Photoshop, and the mosaic was assembled in Lightroom. So very, very nice detail there, Al. Up next is a shot of the Orion Nebula from Alan Hobbs. And this, of course, is a fairly diffuse nebula situated in the Milky Way, in just south of Orion's belt in the constellation of Orion. And it's one of the brightest nebulae in the sky, and it's visible with the naked eye at an apparent magnitude of 4. And this was taken from Alan's driveway in February 2024, just last week. And this was a result of 59 subs of 1 minute each, so total about 1 hour of exposure time. And it was taken with Alan's RASC 8 and ASI 2600 MC Pro camera, and also an Optlong L-Enhance filter. And processing was done in PixInsight and Photoshop. So great shot, Alan. Up next is an image from Mark. This is an image of the NLC bands and the headless hawk, as Mark called it. And the picture was taken shortly after midnight on June 20, 2021. Or sorry, June 20 or 21 night. And Bruce McCurdy likened the hawk more like Jonathan Livingstone's seagull. Not quite familiar with that reference, but a very nice shot of the NLC, Mark. One more shot from Mark, and this was taken at about 1 p.m. on November 16, and this is a rare November rainbow. And Mark said it was weird to see it almost due north. And also note the additional arcs below the main arc. And Alistair Ling explains that these extra arcs are called supernumerary arcs that are caused by constructive and destructive interference from different path lengths through the raindrops, which are not spherical but more flat-bottomed, hamburger bun shaped. Well, that's good to know. I always wondered what caused those. Up next is an image from Hans, and this is an image of the Pelican Nebula, IC5070, and the wall section of the nebula is visible over here, and this is about a total of 13 hours of data, 10.5 hours in SHO, that is the Hubble palette, and 2.5 hours in RGB for the stars. And again, this was done with the ASI 2600 MC Pro with a Celestron Edge HD 9.25 and a focal reducer. And the processing was done in PixInsight. Nice shot, Hans. Up next is another one for Hans. This is one of my long-term favorite targets, NGC 1333, also known as the Embryo Nebula, and this was shot under Bortle 8 skies, so it's not ideal since this is a reflection nebula, but Hans says that he wanted to see what he could tease out, and this was 640 minutes in RGB with a UV-IR cut filter only, and 320 minutes with HA and an O3 filter, or combined, which is an Optlong L Extreme filter. And the colors in the brighter regions turned out fine, but the shadow does show a bit of contrast, but not a great deal, Hans said, and it was shot through the same Edge HD 9.25 at f7. I think that looks great and better than any attempt I had at that nebula so far, Hans. So great job. And one more shot from Hans. This is the Orion Nebula. This was taken from Hans's backyard using about 1 hour of data. And this was with a NP127IS refractor at 660 millimeters. And only 24 minutes of RGB data was used to produce this amount of detail. So yeah, I think that turned out excellent. And next is an image from Josephine, and this is the Crab Nebula. Now, interesting thing about this image was that it was taken with the ZWO C-Star S50. That's one of the new smart telescopes that are super portable and small. But they produce very good results. And this was a combination of 234 frames of 10 seconds each at a focal length of 250 millimeters and an aperture of 50 millimeters. And the S50 is a triplet apochromat. So for the roughly $600 or so that it costs, I think that's a great deal for the amount of detail you can capture, and especially for the ease of use. So this was taken from Southwest Edmonton, the Windermere area, from Josephine's driveway. So a great shot there, Josephine, and thanks for sending that in. One more shot from Josephine. This is again with the C-Star S50, and this is that gigantic sunspot group that's been visible on the sun all week. I've been visually monitoring this group as well since it came around the sun, and it's absolutely massive. So I'm glad solar maximum is finally here. Up next is the annular solar eclipse. This is a video. Let's see if it plays. Oh, there we go. There we go. So this was taken with a William Optics 71 refractor with a Canon 1.4 converter on the Canon 80D DSLR. And this is the eclipse from Belize that Murray had imaged. And this was 121 total images that were put together. And they seem to be jumping a little bit, but yeah, you can definitely see the entire sequence. Perfect. Thanks for sharing that, Murray. And up next, we have an image from Ray. This is the Flame Nebula from a recent timeout. And this is a combination of 5-minute exposures and 24 of them. So for a total of about 2 hours. And it was with a QHY 268C camera with a 132 millimeter William Optics refractor. It was stacked in APP and processed in Lightroom. So great shot. Next is a wide field shot of the aurora from Warren Finlay. And Warren said that he was doing some deep sky observing on December 16 with this scope just before midnight. And when he saw a small band of aurora in the north starting to get brighter, and it began to cover much of the northern part of the sky. So he put his scope away and got his camera gear out and captured this photo. And the solar wind above was joined by terrestrial wind gusts of up to 30 kilometers an hour, where he was located just east of Edmonton. So beautiful shot. I think I see the double cluster up there. Yeah, great shot. Up next is a shot from Tom Owen. This is the Helix Nebula in Aquarius. And this object is too low on the horizon for Tom to image from the lake. So he was happy to be able to see it above the roof of the VBRO in Palm Springs. And Tom says it was still fairly low and it was setting quickly at that time of the year, but he was able to get 2.5 hours of data on it over several nights starting November 25. And the imaging gear was a 90 millimeter triplet refractor and a QSI 683 camera. And it was all logged past overly interested airport security on the flight down. I'm not looking forward to that when I'm going for the eclipse with my imaging gear. And Tom said he also tried out his ASI 585 planetary camera as an auto guider, and it paired well with the Orion 60 millimeter guide scope. And because of the bright and waxing moon, it was imaged in narrow band, so 13 exposures of 6 minutes each in HA and O3, and the subs were stacked in APP, that's Astro-Pixel Processor, and processed in Star Tools. So great shot there, and yeah, I like the little faint wisp of nebulosity you got on the outside as well. So great shot, Tom. Up next is an image from Tim Black. This is Jupiter from November 27. And this was with a Celestron 180 millimeter Mac, ASI 120 MC camera, and the Skywatcher AZ EQ5 mount. And this was a stack of multiple video frames. Up next is there we go. This is an image of Jupiter from October 9. with the same equipment as before. And you can see the great red spot and the two large bands on the surface. So great shot and lots of detail there. Another shot from Tim. This is the eclipse from April 20, 2023. And this was taken with an OM1 mirrorless camera and a 300mm lens with a 1.4x teleconverter on the Skywatcher AZ GTI mount. Great shot. And another one from Tim. This is the solar eclipse, April 20, 2023. And again, shot with the same mount. And this one shows a lot more of the prominences along the solar edge. And this is a shot from David Fielder. This is the Sol Nebula. And so this was taken with the ASI 1600 mono camera. And it was... Let's see, regarding the Sol Nebula, it's also known as IC 1848, and it was first discovered in 1787, and it's about 100 light years across. And this image was taken with an Edge HD 8 with a Hyperstar V4 and the ASI 1600 mono camera and Baudelaire high-speed filters. And this was using the LRGB for the stars and, of course, the HA03 and S2 filters for narrowband. And the total exposure time for this was 32 hours, and it was processed in PixInsight using a combined 4-ax and normal channel combination. Beautiful shot, David. That's 32 hours, well worth it. Next shot is from Zed Lorca. This is the aurora above Estotin Lake near Elk Island National Park, and taken November 30, 2023. It was taken with a Nikon D5600 and a 35mm lens. So great shot. And up next is one of my shots, and this is actually from last night. Through a hole in the clouds, I was testing out some cell phone astrophotography. And this is a, well, I guess a single image, even though I was using the Astro mode on my cell phone, the Google Pixel 6a. And so it took several short exposures, totaling a total of 4 minutes. And I had attached my phone just to the eyepiece of my telescope, which was tracking. And this was an 8-inch reflector. No guiding or anything, and no further processing on the phone. So this is basically just the image that my phone gave me. So I got some great results doing cell phone astrophotography, and I'll be sharing some of the results and some tips and tricks at our next at the presentation I'll be doing on February 21st. So more details on that at the end of this meeting. This was one of my fairly recent images. This was I forget, oh yes, between November and December 2023 is when I initially got some data on it. And this is Sharpless 224. I forget what the actual name of it is, but my wife calls it the Pretzel Nebula. So this was taken with an Orion 8-inch f3.9 reflector and an ASI 294mm camera. And this is a total of 65 hours of exposures. And this was taken from my Portal 6 to 7 backyard in Cochrane, Alberta. And this is SH2-224, as it's also known, is a very, very faint supernova remnant in the constellation of Auriga. And since it is so faint, it requires long exposures and good transparency to capture. So it took me over 3 weeks between multiple nights to get enough data to be able to pull out some detail in it. But overall, I'm pretty happy with how it turned out. And this is one of my images from the Northern Prairie Star Party. And this was with my C11 Edge Hyperstar and ASI 2600 MC camera. And this was a total of 22.5 hours from the Northern Prairie Star Party, dodging high winds and clouds. I would say I was only able to use about 1/3 of my total exposures due to wind ruining the other 2/3, but luckily that 1/3 totaled about 22.5 hours, so I was pretty happy with the results. And this was taken between September 13 and September 17 while I was camping out there under the giant scope. And this object, also known as the Ghost Nebula, is a reflection nebula in the constellation of Cepheus, and the region contains a large amount of interstellar dust and gas, which is being lit up by the stars within it. and the gas and dust is what gives the nebula its yellowish brownish color. And that's the end of our images, but I just wanted to give everyone or send everyone a reminder that on February 21st, 2024, I'll be presenting an Astro-Imaging for Beginners talk, and that'll be from 7 p.m. to 9 p.m. And it'll cover topics such as choosing your equipment, cell phone astrophotography, smart telescopes, choosing between mono and color, some recommended settings that I would recommend, programs and planning, and calibration frames. So if you're a beginner in astroimaging or you've never done any imaging but you want to get into it and don't know where to start at all, just be sure to drop in. And that is it for this month's images. So if you want to send some of your images, you can find our link on the left panel at the RASC Edmonton website. So thank you to everyone who sent in some images. And back to you, Jay.
All right. Thank you, Abdur. Just incredible. Some of those are absolutely incredible images. All right. Hey, look at that. It worked? What? So close yet so far. All right. Think it's that one. All right. Okay. Thank you, Abdur. And thanks for everyone that submitted your images to the Astro-Imaging Corner. Okay, home stretch. So we'll just go through the astronomical trivia. Again, just quick. We had this guy. So does anybody know what the name of the object is? NGC 2261.
It looks like Hubble's Variable Nebula.
Yeah, it is. Oh, there we go. And so there we go. Can we see that? Everybody see that? Maybe not, but that's right. Hubble's Variable Nebula, NGC 2261 or Caldwell 46, also known as Hubble's Variable Nebula and constellation Monoceros. And the reason I brought this one up, I thought was interesting, is it's deemed a variable nebula. And it's because the star that is exciting those gas particles is a variable star, and so it varies in brightness over time. And as you can see, the big amateur telescope collected images over several months, and you can see sort of, I can't quite see from here, but the brightness of the nebula changes over time. And of course, that's directly related to the star itself. And Monoceros is rich with many interesting objects. So it's got Plaskett star, which is a massive binary system. It's about mag 6, so you can actually see that. Schultz star, which is a red and brown dwarf binary, which you won't see. It's about mag 18. Contains one of the nearest black holes to the Earth. Contains 2 super Earth exoplanets. And then the more commonly known objects of M50, the Rosetta Nebula, Cone Nebula, and the Christmas Tree Cluster. So all interesting objects, and you can see there roughly where it is from Monoceros. Okay, upcoming events, and I think there's a couple of things here that'll be of interest to everyone. So our observers meeting, hosted again by John Stolte or Berta Beltran on February 14th at 7:30. And we also have our Astro-Imaging for Beginners, again, that Abdur alluded to just a little bit earlier. So again, there's only 100 seats, so book early. I don't really know what that means. It's a Zoom meeting, so just show up early maybe. But I expect it to be well attended and very informative. It's going to be part of a series of workshops. So the first one will be the capture of the data. And then we'll hold several workshops based around different types of processing software. So we'll have a workshop on Serial, on Photoshop, on GIMP, on PixInsight, that sort of thing. So stay tuned for that. And again, as Abdur said, if you're interested in getting into astroimaging, this is definitely the thing for you, the workshop for you. Unlike my mouse, doesn't want to seem to work here. Come on. Oh, that's crazy. Come on. Okay, I don't know why that's like that. Okay, go back to there. Right, what's up over Edmonton? So Jeff Robertson again for our what's up for the month. So that's on the 28th. Our next meeting, of course, is March 11th for the monthly meeting. Photometry for beginners, we're still working on that. We're trying to get a dry run in here and the weather's just not cooperating, but look for that in spring. And then a couple of announcements, just quick membership fee benefit program. Again, we've been talking about that for a while, so it is now up and operational on our website. So if there's someone you know that you think can benefit from a RASC Edmonton membership, please check out the benefit program. And then the Edmonton Centre apparel. So I mentioned this in our last meeting as well. So I've mocked up some things just so folks can see. This is roughly what it is. The coats, that's the type of coat that we will have, and that's also the kind of hoodie. I've just used my wizardly designer graphics skills to put the logo on there as to what it would roughly look like. That's what my wife calls artificial intelligence. But anyway, so we will have the Saturn logo available to go on the jacket or the hoodie. And then we'll also have hats made up, one that we can also put the logo on, or we'll also have a patch of the RASC Edmonton Centre logo. So we're just putting together the final pricing on all that. And so that should be available for folks to order in the very near future. And so having said that, thank you everyone for coming out tonight. And that's the last thing on the agenda. So enjoy the rest of your evening and I will call the meeting adjourned. Thank you.